Welcome. Today we're going to be talking about OpenSees-on-DesignSafe training because I have created a training document and I am introducing this to you so that I can actually get you started on using OpenSees-on-DesignSafe, give you an overview and introduction of what's in the training content so that you can go in as deep as you like in learning what you can do with OpenSees-on-DesignSafe. So my name is Silvia Mazzoni. Many of you know me from my involvement with either OpenSees or the NGA ground motion world. I've been playing with OpenSees since its inception, pretty much, since Frank published it, and I started playing with it. Lately, I've even become a developer. I've done some development on it. You've seen all the training documents, all the OpenSees manuals. That's all content that I've generated. Therefore, all that is aside. What we're going to talk about today is running OpenSees on DesignSafe itself. I'm an application specialist at DesignSafe, and let's get started. This is great. We already have one hand up. Hi, Farzad.
Hi, Dr. Mazzoni. I was wondering if the syntax of the OpenSees that is technically implemented on design-safe servers is just like OpenSees Pi or OpenSees TCL.
Well, you're
Just
in the right
wondering.
place. That's what we're going to talk about today.
Nice,
So,
nice.
and the answer is yes to both.
Oh,
So
perfect.
it's
Thank
all
you.
there. Anything you want to do, you can do it on DesignSafe. And every day I'm learning something new that we can do there that I'm always happy to pass on to the community. And that's my job at DesignSafe. I think we have quite a few of you. We're going to leave time at the end for more off-topic questions. So if you have questions or interruptions on what I am covering, go ahead and let's do so. If not, go ahead and write down if you want in the chat. You can just put for later, and it's a discussion that we can have at the end of the session. Okay. Our next meeting is at 3. You don't know what time zone I'm in, but I have time after this meeting to stay on and discuss. And then there's a lot of other resources available, especially Slack channel on DesignSafe that we can follow through. Okay, we are recording this video, so this is going to be a getting started on this training module for people who weren't lucky enough to be here in person today. All right, let's see what's in the next slide. I keep changing these slides. So the objective for today is twofold. There's 3 parts to it, but it's really twofold. One is what I give to you to give you an overview of OpenSees on DesignSafe, what's available, and the different ways that you can run it, and introduce you to this training document that I've developed. I keep developing. I'm going to be adding some new things and more advanced things to it, but I'm pretty happy with where it is now. But more importantly to me and selfishly, I would love to get a better understanding of where you as a community are in how you're running OpenSees, what kind of analyses you do, and what the different needs are in running OpenSees on DesignSafe. Okay, so that's why I don't want to be a talking head. I would like to just ask questions and get some discussions going. All right, and some of you have been in other workshops or have attended things that I've done. My goal is to have you walk away with more questions and answers. All right. I want you to walk away curious, to go, oh, what was she talking about? That really cool way that you can run OpenSees Tickle in a Jupyter notebook. All right. I want you to go and try it because I can't cover it all today. And so my goal is to make you curious and let you know, hey, there are all these different things that you can do. Because once you know you can do something, then your own curiosity and experience can take you down that path of what to do with it. Okay. So that's the objective for today. Hopefully we will achieve it. I would love to kind of get some interactive part on this. I didn't want to set up a whatever it's called, a poll. So I don't know what happened here. Somebody is, that's cool. I think it's somebody who's trying to share. Okay. I want a hands up on, I'm going to go through these different items and I would like you to raise your hand up fast once I get a count to put it down. And I want to go through each one of these items. This is where I get to learn, and I'm going to take a picture to record the numbers, okay? So I want to go through each one of these items, and I want you to respond about your experience level, all right? You decide where the boundaries are between low, medium, and high. And if the answer is none, then you abstain from answering, okay? So get your finger ready um, on your mouse. All right. So OpenSees Tickle Interpreter. How many of you are using it, have used it, experience level right now with OpenSees with the Tickle Interpreter? All right. We got 2 high hands up. Ooh, Andreas too. All right. So we got 5 people here out of 6, 5. Okay. So I'll take the number 6. Okay. So I'm going to take a picture. I'm going to stop there. All right. Go ahead and take your hands down. Then with OpenSees MP, how many of you have experience with OpenSees MP itself? We got Andreas. All right. Oh, OpenSees MP is fun. All right. So we've got 2 hands up for that. All right. Thank you. Go ahead and put your hands down. OpenSees SP. Do we have geotechs that do some big analyses on there? All right. We've got 2 people there. OpenSees Pi. Should I raise my hand on this one? All right, I'm going to give you a little bit of time to respond on the OpenSees Pi users. Yes, this is cool. Good numbers. All right, so I've got 12 people. I'm going to take a screenshot of that. All right, go ahead and put your hands down. OpenSees Pi MPI. So if you run it in parallel, not using concurrent futures, which doesn't require an MPI. Okay, so comfortable with your choice? Final answer? So I've got 3 people on that. How about OpenSees Pi with concurrent futures, which doesn't somehow magically doesn't require MPI? Okay. Oh, well, those of you who don't, put that one down as something you want to look up. It's really cool because it's a great way of being able to run parallel things on your desktop without requiring any sort of complicated setup. Okay, so now we're shifting over to DesignSafe. I'm happy to get some numbers, by the way. All right, Dewan, are you just going to keep your hand up? Okay. OpenSees-on-DesignSafe, submitting jobs through the web portal. How many of you have? Oh, I was supposed to go to low, medium, and high. Forget that. So just answer if you have experience with it, I guess. I don't follow directions. All right, nobody here has. Oh, I'm taking pictures, but I don't have the answer, the question that I'm asking. That's fine. All right, so that's a neat way of running OpenSees on DesignSafe. It's a great in to running your first time running on HPC and DesignSafe. So we'll talk about that today. How about OpenSees on the DesignSafe Jupyter Hub? Any OpenSees in the Jupyter Hub in DesignSafe? Okay. Oh, okay, good. There's a lot of fun to be had there for you guys. And then what about Jupyter Hub at home? How many of you run, I guess with OpenSees Pi would be if you run it in a Jupyter notebook or not? Interesting. So do most of you run OpenSees Pi on? All right, that hand came up. So how many of you run OpenSees Pi in IDE, such as Spider or I don't know what the other one is that I tried? Okay, and so that's what you do on your desktop. Okay, that's good. Time to step up the game. And then OpenSees and Tapas, submitting jobs directly, which is really the ultimate goal of what we're going to be doing today is using Tapas. Okay. Oh, Wasak, you've done this. Okay, cool. Good, good, good. And then the last question is OpenSees on HPC, so on Stampede 1, 2, or 3, using the SSH and developing Slurm jobs. Okay. This is, I have my hand up on this one because this is how my first experience was at DesignSafe, I was able to run, if you've seen the work that I've done on the inelastic spectra database, I ran all those on DesignSafe and I was creating Slurm jobs, but then and it was just millions and billions of tiny little analyses because I was computing raw D50s and everything. And I was writing Slurm jobs, submitting 20 at the time. You had a limit of 20 jobs at a time, but then I would run out of time. So I would have to see, oh, what got run, what didn't run. And I was doing this all manually. And so my goal has been to get you to the point where you can be a lot more efficient with your time, but being able to run that kind of jobs. Okay. And that's where OpenSees is at for on DesignSafe. And that's the ultimate goal for you to support you in the type of analyses that you're doing. Okay. So thank you everyone for participating in my big poll here. All right, let's see what's next. Trying to get to the next slide. Oh, I need to go on. I know what happened. Okay, I was in the window. Okay, so the outline of today is when I learned English, I thought this WH concept was just the greatest thing. And my ESL teacher told me how to pronounce it. It was the word whisper. And so she whispered it, and I learned the WH sound. And so I like to use it with English a lot on the why, when. I guess today we're only running those two, and how of OpenSees on DesignSafe. All right. And the big one is how to run it on DesignSafe. Why? Because if you look at where we started, my very first example in the examples manual is a simple elastic section with elastic section properties. You do a gravity load, and that was the very first script that we've all run. You could do that on your laptop, and it generates 3 files, one for forces, one for displacement, and one is your input script or something else. Okay, very few files, very simple. But now we want to do something bigger. And so we want to scale. You want to do more models, more different types of models. They may be big models and small models, which have different requirements and different types of OpenSees, as well as, of course, many different loading conditions. You could be running an IDA or anything like that. You can have many different loading and ground motions or wind and other loading possibilities there. I'm a structural engineer, so I show buildings here, but you can imagine that you have your own other models representing the geotechnical layer of your model. Okay. And so the point of in DesignSafe, you have scalable resources and environment. Okay. Environments of different ways that you can interact with OpenSees and DesignSafe on TAC. Important, if you look, the different processors, these are different types of computers. We have different types of nodes, different types of processors on DesignSafe. So it is not only a number, but it's also different types and different applications that you would have for GPU versus CPU nodes and different types of analyses, as well as the data storage. You no longer have a few files. You may have a lot of different files. And now you got to talk about where you're going to store the data. And that's something very important to think about because I always say it, what really slows down the most, what's going to take up the most time in your analyses is the I/O. Okay, input and output. Every time you write to a file, you save to a file, or you doing something, that takes time. And so if your file is really across town and you have to deliver it over there, it does have a latency there compared to if it's on the node itself. All right. And so if you look at AWS, for example, which is a whole different world, they've got different tiers of different regions because that's really the key is, the closer your data is to your processors, the faster it is. And so that's something really important that you need to think about when you're designing your analyses, and they're very much customized to what your needs are. All right. So we got these scalable resources as well as adaptable resources. As I was saying, we have many different types of processors and nodes. There's GPUs and CPUs. We've got large memory nodes, and we've got cheaper, faster nodes. So it really depends on the type of analyses and what your needs are. Now, in my days, it was life was simple, and we just scaled up different types of models. But the big applications these days with OpenSees, and it's really cool because now it's no longer just about OpenSees, it's OpenSees as a tool in your workflow. And that's why it works really well in DesignSafe is, let's say you're doing Monte Carlo analyses, right? Where you've got some sort of random samples, you've got a distribution on that, and you're trying to run a lot of analyses that are independent of each other. Same thing with a parametric sweep. It's more of a rectangular matrix versus, different distributions, but they're very similar concepts, right? So you've got a lot of just independent parallel analyses going on. They may be small if you're doing a really large number, so you've got one type of need. Then we've got the machine learning loops that are a different type of process, right? There are a lot of them. It's a training, so you do it on one set of data, then you test it on a different set of data. But machine learning is a type of interpolation. It's a simplified model. So you're really solving the same equation in for many, 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 too many different parameters. So now you can bring in your GPUs because you're doing relatively simple calculations that are really large number. And maybe you may have some dependency between the different types of analyses, which then brings you to coupled simulations, where you're modeling, maybe you're doing hybrid testing, or even just you're modeling the one program OpenSees does your structure and your soil, and maybe you're using a different program to model the fluid, and you're communicating between these two different analyses. So you're doing soil structure fluid interaction, let's say if you're doing tsunami studies. So now you're requiring a different type of communication. You've got much larger models, but maybe you're only running a few scenarios of them. But speed is important because you've got two concurrent analyses. And so you want one to keep up with the other one. Typical one is the next one, which is the OpenSees. This is stepwise because you're doing a time history. If you're doing a nonlinear response history to earthquake or wind loads, there's a step dependence there, right? So now you've got a history. If you're doing nonlinear, you've got history, and you have a lot of data that you need to keep track of as well. And so you've got different needs, and maybe you're running a lot of them, or maybe you're running a really large geotechnical model. And then, which is something we don't think about, but I did this the other day. I had to generate a lot of figures, and my desktop was getting frustrated because I had a memory leak, and I just didn't want to deal with fixing the memory leak. So I just loaded up on DesignSafe, and I just did it. Even though I didn't parallelize it, it was just a lot faster and easier to manage. And so that's something to think about too, in just post-processing these large data sets. That maybe OpenSees is part of it, or it's the results of your OpenSees. And so you've got different needs, and that's why it's not just scalable. It's not just that many more nodes, but you get to choose which types of nodes you want to use. And maybe you can use, the best thing is to use different types of nodes for different times in your analyses. And I talk about this a lot in the documentation that goes with the training documents. But I wanted to put this out there because it's something that I want you to start thinking about as you're designing your analysis. It's not just building your model, which you probably already have a script, is okay, now I want to step up. What do I do? And it may be worth breaking down the different components or actually bringing the whole workflow together. And that's the power of DesignSafe on top of tech, is that we have these different applications and environments that you can work. And we've got the user support, such as me and the different application specialists that we have at DesignSafe. So that's when, and now today we're going to focus on how to run OpenSees on DesignSafe, all right? And this is a key figure that you're going to see again and again, and this is how I want you to imagine the world that I live in, or that we will all be living in when you're doing your DesignSafe or your OpenSees analyses. So we've got three different, and this is kind of simplistically, and this is very much thinking of OpenSees in mind, okay? So this is not limited, but this is the focus of where my realm, all right? We've got three different ways that you can interact with the compute environment, all right, with the computers that are available at DesignSafe. And TAC. All right, TAC is the supercomputer. DesignSafe is the layer that enables researchers to use the TAC resources in a more efficient and effective and collaborative manner, so that we can focus on research versus having the fun of doing this. I mean, this is kind of fun in itself, but sometimes we want to take this and being able to, move on and just use it as a tool. All right. So the three ways to interface, and this is something at DesignSafe. One is the Jupyter Hub. That is awesome. It's a great environment for remote work. I mean, Spider's nice and fast, and in the end, the fastest way to do it is actually on your little submit, python.input.py on your bash prompt, and that's actually the fastest way to do it, right? But I really like the whole IDE that's in the Jupyter Hub. That's a step up from the old days of just having a Jupyter notebook. And we'll talk about that. And there's a lot of information on that in the documentation that goes with the training document. There's a web portal that we have. You can submit jobs. There's a really nice pull down menus interface. It's a great way of, you don't have to know what's behind. I like web portals. I like well-designed UIs because they give you pull-down menus and they give you choices so you don't accidentally type something or you don't quite know, well, what do you mean? Well, it's not an open-ended question. It's like choose what you want to do. And so it really integrates almost a type of documentation for you. So that's a great tool that we have there. Right now, it's works for OpenSees Tickle interpreters, but I'm working on being able to submit jobs for OpenSees Pi on TAC as well through the web portal, because it's a great place to get started when you have to submit a job or so. And the third interface is the command language. You just SSH from your laptop, from your desktop, you just connect to wherever you want to connect to, all right? You can connect to the Stampede 3 and work directly there. And that's world that I lived in. That's wonderful, gives you a lot of power. But if your interaction is not programmed, you can write as many bash scripts as you want, but being able to make that programmatic, which is what we do with Tapis, and you see how there's a Tapis is an API that this path doesn't cross. And so it means you have to do everything manually. And Tapis fills in a lot of tools and a lot of processes that should be automatable. Instead, you're doing it by hand, even if you're just running a batch script. And Tapis makes that much easier for you. Most importantly, is just loading up files to the right place and submitting jobs to TAC and to this Learn project. And so those are the three different interface environments, the different ways that you communicate, that you as a user go on, and that's what you see on, they're all kind of, on your screen, let's say. Then we've got the compute environment. We've got a lot of computers out in the middle of, it's not, I don't know where Austin is, somewhere in Texas. I don't know if it's in the middle, it's there. And we've got, right now for OpenSees, we're looking at three different types of computer systems, okay? One is the HPC system. Let's start on the right-hand side. We've got Stampede. Right now, the latest is Stampede 3. It has a lot of nodes. There's a new system coming on that's Vista, that's supposed to be faster. There's some systems, there's Lone Star. It's really cool. I was there one time, and there's some systems that are not, so Stampede is air-cooled. These are liquid-cooled, so they actually sit in an oil bath. And so those are systems that maybe they're not so large and they don't have so many nodes, but they have a much faster network, let's say, whatever it is that, heat is often, the limiting factor in what you can do with your computations. So there's many different HPC systems. Within those systems, there are some virtual machines. These are individual systems that are, out there. that don't have the long queues. They're typically designed for different types of job and specific jobs. They're much smaller. Maybe they're single node machines. That's what we use for OpenSees Express on DesignSafe. What's nice about those is that there is no queue. To submit a job to the HPC, there's so many jobs going on at the same time that you package your job, and that's what Tapis is great for. You submit it, and then you wait because the system has to find the resources that you need. So it asks you, okay, how many nodes do you want? What types of nodes do you want? And as soon as those resources are available, then your job gets submitted. It's a lot more interesting than that because it's a fair use policy, and I talk about it in the documentation as well, but that's the main concept. On a virtual machine, you don't have to wait, but it's a much more limited resource. And so a lot of times it's handy if you have a simple job to just submit it to the single processor OpenSees tickle on the virtual machine. And then there's the Jupyter Hub containers. If you're not familiar with Kubernetes, it's a really neat way of deploying little environments. And in this case, for DesignSafe on TAC, it's set up as a Jupyter Hub environment. So you've got your own little system where you can actually run OpenSees, and I will show you, and it's in the documentation. You can run OpenSees within there. It's a single node. You have 8 processors and a certain amount of memory, so it's a great place to stage and test. It's a great place to run OpenSees Pi in your Jupyter notebooks there. There's a lot of things that you can do even directly in the Jupyter Hub itself. So I've done the 2 extremes, and I've mentioned what this Tapis is. Tapis is an API that was developed. It's Texas application. Well, it's a Texas it's a TAC API. All right. It communicates and it does different jobs, submits jobs on TAC, as well as it manages your files. You can use it to move files and automate file movement during your analysis process. Okay. And it does this all behind the scenes for you. So it's got a lot of shortcuts and a lot of really nice features that allow you to work with the hardware within your software. And that's easily accessed by the web portal. That's how the web portal submits jobs to Tapis. And you can also access it from Jupyter Hub because there's TappyPy, which is an API. It's a Python API for Tapis. So you can submit the commands through in your Jupyter Notebook. And that's how you could do that even in a Jupyter Notebook in Python. Submit your tickle jobs because you're managing your process within there. What are the advantages of that? Is you can do your pre-processing and your post-processing directly in Python. So even if you use a tickle interpreter, which I think for OpenSees SP, it's really handy, you can still use Jupyter and Python to manage your workflow all within DesignSafe. Okay. And so the 3 different ways that you can submit your OpenSees jobs, and this is the target of and the main topic in the training documents. There's 3 training modules that have a lot of subparts to it. So the first one, and I've talked about these different ones, is the web portal. All right, so you can submit your job through the web portal. This is a great starting place. It makes you aware of what your inputs are and what you need to do. You don't have a chance that you may have spelled something wrong. And so if you have an OpenSees MP input file or OpenSees SP or even just a regular OpenSees, you can submit these through the web portal. Trivial, and I will show you how to do that. And you can prepare your files in DesignSafe in your Jupyter Hub before, and then you can also do your post-processing there. All right. I find it's a lot faster than doing it on my desktop because 1 is the data is already there. 2 is it's a lot, my desktop has a lot of other stuff in its memory and its data access and things like that it actually, as much as maybe the CPUs may be faster in my gaming computer, I may have more. Everything else just slows everything down on my computer compared to even just doing things on the Jupyter Hub or on DesignSafe. All right. So this is the very first way that you can submit your jobs your OpenSees analyses, any tickle interpreter, and soon, I wasn't allowed to put this out until this webinar, and I keep on adding things to it. We will have being able to submit OpenSees Pi jobs to the portal. Okay. The other way to do it is to run things directly in Jupyter Hub. There's a lot of things that you can do on the Jupyter Hub. I highly recommend testing your project, your analyses in the Jupyter Hub. It doesn't cost time. There is no queue to run your jobs because you've got your little Kubernetes world that you're working in. So you can test, 2, 3, even 10 analyses on there. And then also there's no time limit. So you can do some interesting deployment directly running things in the Jupyter Hub. All right. And so this is a great stage to then go to the next that you've worked your input scripts. You're able to run them through the web portal for one type of project, and then you want to scale up. You test it in the Jupyter Hub, and then the third way to do it is to have these files and submit them through Tapas to the virtual machine or to the HPC system. And as you can see, it overlaps. It's doing exactly the same thing as the web portal is doing. But you're doing it programmatically. So instead of having to do the pull down menus and finding your input for your 40 jobs that you can submit at one time, I don't know if it's 40 or some fraction of that. Now you can like programmatically submit many jobs at the same time. And you can even monitor them. You can look at the results. Tapas, it's a great way of seeing what's going on in DesignSafe and TAC and your jobs. Any questions up to this point? Okay. You excited? Oh, and then there's the last way, which we're not going to talk about, but I've mentioned it before, is working directly and building your own Slurm jobs, moving your own files, setting up your own things, and keeping track of your jobs directly by SSHing to TAC. I'm not going to talk about it today. The focus of today and the documentation in the training modules is up to that point, but I do have information on Slurm jobs in the content that goes with the training online. Okay. And so all of these are covered, but I really want to focus on these because the point of number 3 is to automate and make things easier so that you have enough control, because sometimes doing things yourself and manually, you have full control. But Tapas actually gives you, and if you're willing to invest the time into learning it, it gives you a lot of really cool options that what it can do. So that's where the step 3 is really where I think you can even stop in what you're trying to do. It's not like SSHing is a more advanced way of doing it. It's a lot less efficient way of doing it. So I'm excited that we don't have to do it that way. So the training is online. I realized that I haven't published the URL, mainly because that was the point of today. And I am not going to post it, actually. I mean, if you go on GitHub, you could find it. Oh, actually, I show you here how to do it. So this is the document that's online. It's on GitHub, but it's actually, you access it from DesignSafe. So if you have an account, number 1 is to have an account on DesignSafe. If you go to the user guides in DesignSafe and you look on the left for training resources, I'm trying to have that little link there to be moved down so that spot is not fixed. And you open up the training resources. The very first one is the OpenSees on DesignSafe. All right. And so that's the document I created. It's there. I keep working on it. I keep on adding. I keep on improving. And so please provide me feedback. It's something that I developed over time, and I've built a lot of different parts, and then I brought it back. And I want to make sure that it is clear and helpful to you. So if there's issues or questions on it, because it's on GitHub, it actually has the little button at the top. Click on it and submit an issue on GitHub. If otherwise, if you just have general questions, So if you have recommendations or questions, technical issues with the documentation, go ahead and submit it on GitHub. But if you have general questions on running OpenSees, there is a channel on Slack, and I'm going to put this list at the very end of the webinar. There's a channel called Running OpenSees-on-DesignSafe User Issues. I made it so long that it does stand out in your Slack world. So it's going to be easy to find. So make sure you join that channel. That is the channel for asking questions on how to run OpenSees on DesignSafe. There is an OpenSees channel, but that one is for questions about OpenSees itself. All right. That's a whole different type of questions. And if you have questions or issues and things, I'd be great. You can always message me, but if you post them on that channel, then others can learn from it. And we can evolve, or somebody else can say, oh, yes, I was having this problem and this is how I fixed it. When, of course, I never have any problems. So I think there's a lot of usefulness in creating this community that is specific to running OpenSees on DesignSafe. And if we can all learn from each other, I'd love to learn what other things we can add to this. Okay, so this is the document. You click on it, and it takes you to this page. So the cover page I already showed you, and I don't know what it says. I think it's just got my name and information on it. Now I've lost. Yes. Okay. So the very important part is the training objectives. All right. I talk about all the different goals and the different ways what the different things that you're going to learn in this module. And the most important thing is, even though this whole training guide is focused on OpenSees, I put a lot of content on just general information on learning about HPC systems and nodes, and a lot of really neat things that I learned along the way in using OpenSees on DesignSafe as well, and just developing this this document. Because it's easy to just do things by muscle memory. It's another to have to explain why I have made every step. So you'll see my documentation sometimes gets highly detailed, because I think there's really cool stuff to learn why certain things work in different ways. And if you're willing to invest the time in it, you can learn a lot of flexibility and different things that you can do with OpenSees on DesignSafe or anything else on DesignSafe. Okay. Important that I talk about is still at the beginning. There's training material. There's training notebooks, as well as some basic examples that are great to get started. And then there's these OpenSees utilities, all right? So it's a Python, I realize the right term is wrapper, all right? I have created these Python wrappers that just make your life easier, right? Create input, puts together, it's like they're just a bunch of Python functions. They're all on community. I show at the top of each of these notebooks how you can import it. So it's as if you pip installed it, but you're not pip installing it because I don't want to create a wheel to put it somewhere, and because I'm always just adding on and doing different things. I've set it up in community. Because everyone has access to community, you'll see a little script at the very top of any Jupyter notebook that shows how to import it as if it was something that you have pip installed. Okay, and those are documented. You'll see them here at the very bottom. They're documented. Of course, I keep on changing them. The little script at the beginning of each function, this is what I like ChatGPT for, to generate the little script of it, documented. But of course, I keep on adding features and things to them. Look at them. They're always, I show you the code. You're welcome to look at them. You're welcome to use them beyond what we're doing here. Any ideas, recommendations, or any contributions you want to make to this, just reach out, and it'd be great. Also, if you have issues with them, of course. Nothing is ever perfect, because I'm always trying to add features to it. And so sometimes I get a little ahead of myself, but I'm really good at testing things. So those are two content that are very useful. Now, these Jupyter notebooks, they're in community data, and I will show you when I do the demonstration. You can't write to community data, and therefore, even though these notebooks don't really have to run there? My recommendation is to copy these notebooks, the ones that you're interested in, and put them into your My Data folder, and I will show you how to do that. Now, I'm going to keep on adding and editing and improving these notebooks, so use them as templates. And don't just copy them all and then just be static with that version of these notebooks. All right. That's what I mean by grab what you need, because maybe next week there's going to be something better or some improvements to it. All right. So this is the name of the game as I learn and do more things with what we're trying to do. So there's two parts to this document. There's the reference guides, and I am not going to go. There's a lot of really good content there. A lot of things that I've gone through as I learned, and then I had ChatGPT say, I would just put in all these words, and ChatGPT makes it into nice, stream of consciousness that are readable. So there's a lot of, and for me, I just, it's important to understand what it is that you're doing. It's not just knowing it. Okay. So I've tried to add on my documentation and my things is about understanding more than knowing. And so there's, for example, so there's a chapter on just the workflow architecture and just general introduction. There's a chapter on OpenSees. Okay. Now, this is not an OpenSees manual, but this is a manual on how to run OpenSees. A lot of really useful content here, okay? So I talk about the Tcl versus the Python interpreters. They're both available on TAC. It's how you use them that they're not fully both accessible easily right now. I talk about, which interpreters to use and how they work, because OpenSees Tcl is a self-contained executable file that you just, in Windows, you just double click, right? And that's great. It's portable, but you cannot easily you can integrate it into your workflow, but it's still external to your workflow unless you work in main and in the source code itself. But it's an external, which is great if you want something external, but then you can't query in real time your OpenSees model, right? You could in Tcl, but not in your workflow. And so it's difficult to make it adaptive. Now, the OpenSees Py version, on the other hand, is a Python library. All right, this is something that you just add on to your Python interpreter already once you start up in whatever world you're in. All right, so now OpenSees Py is integrated into what you're doing. You could do certain analyses. You don't have to exit your model. You could do certain things and then requery it or grab things and ask it different questions, okay? So they work very differently. The way, therefore, they're called are differently. The way you would run them in an MPI world, in a parallel world, is different. I talk about OpenSees MP versus OpenSees SP, that there are the distributed computing versions of the OpenSees Tcl interpreter, while OpenSees Py works differently on how it works in the multiprocessing world. I've always used what's it called? Concurrent futures, but that has a limitation that you can only work on one node. So it's great for me when I want to do distributed computing of single simple processes, but you can't use it if you're doing an OpenSees SP where you need more nodes to do integrated type of analyses, okay? And the nice thing about that is that you don't need an MPI, you don't need a manager on top of it. So there's different ways of running the sequential and parallel OpenSees and the different OpenSees, and that's all talked about here, okay? Something that I highlight that's important that I think can step up your game, especially if you're running a lot of OpenSees analyses, is the 3 different options that you have in your command structure. And this works with everything, okay? You've got an executable. So you should just say Python or OpenSees, and then it, poof, becomes interactive. You then give it a script, and then poof, now it runs that script. And most of us stop there, right? But there's a third part that you can add. You can add command line argument. So those are actual inputs that you can say, that you can enter. It doesn't have to read a file in different cases. You can just say OpenSees input script L equals 10, enter. and then OpenSees input script L equal 20. And so you can run different cases and send, it's almost like your script is a function. Now, inside your script, you have to know how to read that. And so I give you all that information. If you're stepping up your game with OpenSees, I highly recommend looking into that if you're doing a lot of parallel analyses. And this is not just about OpenSees, this is even just in Python in general. All right, so command line arguments are a really cool thing that I highly recommend because you don't have that IO of having to read an external file. And then as you see here, there's parallel execution and a lot of different ways. So there's a lot of different ways that you can run OpenSees itself and a lot of different OpenSees. And then there's a layer of different ways that you can run it in DesignSafe. Okay, so there's a lot of content that I've put here. I talk about the Jupyter Hub, a lot of really cool things that you can do there. Running OpenSees and notebooks, because now you can run OpenSees Pi interactively in your notebook, but nobody really runs OpenSees interactively. Is great for testing or documentation, but you want to be able to run jobs in a bigger scale, but you can still do that from the Jupyter environment. Very important to read on that section. This section on HPC talks about resources, nodes, what types of nodes we have. We've got GPUs and GPU nodes and processors. What's a core? What's a queue, right? And so these are all different concepts that you're going to be asked for input, and it's important that you know that you have choices. Okay, and that's what I document here. Very important to get an allocation, which is what you charge to. You can get an allocation for free. You just have to follow the guides and you can get a starter allocation for free on DesignSafe. And so then you have to learn what is the name of your allocation. And that's where I get into the details of Slurm jobs. File storage is a whole other section that's super important. I want to do a webinar on each one of these. In DesignSafe, we have different, or in TAC, we have different types of storage. You've got My Data, which is huge and wonderful, and it's backed up, but it's out. It's far away. It's not connected to your analyses. Then you've got, the storage on the compute system. So we got your work folder. It's not backed up, but it's closer to your computer. Therefore, it's faster to access it. And you can have a lot more data there. Or you can actually put things in the temporary folder of your node. If you need to do a lot of I/O, that's the best thing to do, but it's time consuming to put the files there. So is that really saving you the time? And that's something you need to think about. And that's what I talk about here. And that's important related to the storage because it's stored in different places. We have different paths. And TAPIS is the last section that talks about, TAPIS jobs, submitting jobs to the Slurm, submitting jobs to DesignSafe. And so this gives you all the background that it'd be really great for you to learn about, and you should. But I've developed these notebooks in the training that kind of go beyond that, okay, let's just get to it. And I've written the wrapper functions and I've interpreted all this stuff to make your life that much easier. But you really should, there's really cool stuff that I recommend that you read and learn about in there, okay? Yeah, and in the section on TAPIS, we talk about the TAPIS apps and how they're made up. Again, you don't have to know because I already did the simplifications for you and set up the templates for you, but it's very important to learn about it, that the OpenSees MP and SP are run on Stampede 3, and the OpenSees Express is run on a virtual machine, which has no queue and no wait. So it's a great, fast, easy jobs to run. And these TAPIS apps are what the web portal uses. So you can do it this way, or you can write Python code that sends commands to TAPIS, and that's what's in these Jupyter notebooks. Okay, so there's the 3 ways of running OpenSees that we've talked about, and that's what I'm gonna show you right here, and that's what's in these training modules. So the very first one, here's the, okay. These are the 3 different ways that we're gonna focus on, okay? And I'm gonna show each one, and I'm gonna try to do a live document for you, or live demo. All right. So the very first one is submitting your job from the web portal. In this case, you already have your input script and you're going to submit it, run it. They're going to Tapis is going to take your input files and folder, put them on the HPC, run the job, and put them back in, not where it took them from, because maybe you've done some work in an archive folder, but still in my data. And you can change that if you want to, so that then you can look at the results. All right. You can monitor the job through the web portal as well. And then you could do your post-processing. And so in the documentation, that's how I've broken it up, okay, in these modules. And each one of these is a Jupyter notebook. If it's a Jupyter notebook, you'll see that it's got a little tag on it at the very top that says, open this notebook in DesignSafe. If you open it through here, you can open and play with it, but you can't always write to it. And oftentimes, I'm putting job numbers, and job numbers are associated with jobs that I have run. Okay, but you can take these and you can take bits and pieces of code from it, or you can just, start off right away and use them as a template. But I would use those directly with the last part. So the first part that I work on with you is through Jupyter on creating input, then submitting it to the web portal, and then you can monitor on the web portal, and then you could do the post-processing there. So let's try a live demo, because I like to live on the edge, and a live demo, I don't have to prepare, right? Is it this? Okay, good. All right, I'm starting from scratch because I had to restart my computer as well. All right, so I'm on DesignSafe and I've logged in and I've done all the connections and things. You see it recognizes me and who I am. So I'm going to go on Use DesignSafe. I'm going to go Tools and Applications. And I am going to go to OpenSees, all right? You could go to Jupyter, it kind of takes you to the same. Oh, no, because right now we're going to use the app anyways, right? So if you go to OpenSees, you've got these 4 different options. The first one is to start up the Jupyter Hub. We'll do that in the next example or next demo. And the other one is you could submit an OpenSees Express job, an OpenSees MP, or an OpenSees SP. Express just means it's its own individual, it's a single core processor, right? All right, so I click, I'm going to do OpenSees MP. I've done all my editing in Jupyter Notebook, or let's just start with a yeah, I can't quite go and tap the system there. Welcome to live demonstrations. Oh, come on. Let's see if this runs faster on Edge. All right, let's try Edge. All right, use DesignSafe, tools and applications, OpenSees, and we're going to do an OpenSees MP. Perfect. Okay, cool. One of them is bound, so always have a plan B in what you're doing. Okay. Oh, thank you. All right. So this is your first place to learn about things because, again, as I told you, we've got pull down menus. All right. We're going to pick an input directory. What Tapis is going to do is going to take, you know how, especially Frank used to make fun of me, and now everybody does it because I started doing the many, many different OpenSees files, one for materials, one for sections, and you guys have seen these because it makes the code that much more portable. And so you can't just open up a single script because oftentimes you have a whole lot of subfolders or subfiles that get called by the main script, as well as maybe your input loads, right? So what Tapis is going to do is going to take this whole directory and copy it over. Now, moving files takes the longest time. It actually could take like 90% of your total job time. Therefore, make sure you start off with a very lean folder just for your case. That's my recommendation. Okay, so I'm going to do select, and this is the nice and pane of UIs that I can scroll through, and I can go to, let's go to my community because I've shared those there. If we go to OpenSees, there's training materials. Don't go to the island of misfits, just kind of, all right, so here's our example, OpenSees examples. And right now there's just basic examples. I don't know if Pedro has put anything there. Now, this is the case where we want to take the entire folder, all right? But inside this and right now I don't have that many files there, so good. I'm going to do a little cheat sheet. I'm going to copy this file name. This is going to be the program that I want to call, okay? So this is my MP, and yeah, I have some other ones that tickle, but that's the one I'm going to copy this because right now, and I'm trying to have them change the browser. The next step is going to pick my main input file. I'm going to have to go through the full navigation again. So just copy it. That way I know it's exactly the file. And you notice that file has to be in that folder, right? And at the base of that folder. So I'm going to select, and this is the right folder. Now I'm going to continue. Now the main script, and it only needs the script name. So I'm going to paste the name of what I had. All right. So now it's going to say OpenSees example 1. It's going to be in the folder that I've created. And so make sure that everything references everything within the folder. If you're in more advanced days, I'm going to show you some other stuff that you could do in referencing your own content directly, what you already have in work or Scratch. But right now, this is what we're going to go with. So next, so we just, TDM. Now, these are the allocations. These are the allocations I have available to me. You are going to see allocations that you have available to you. And then the system, it has to be on Stampede 3. Which queue? Oh, this is so cool. They've added things, okay? This is now and if you look at the documentation, we have different types of queues, which is different types of nodes, and they cost differently. There's different amounts available. Therefore, maybe one processor is really fast, but you have to wait 3 days to get on it because it doesn't have 1,000 nodes available to you. And it costs you 3 times as much. So the time that you wait for the job, maybe your job could have just been finished. And therefore, you might as well just use the cheap nodes, which are not cheap, the SKX. Now, I'm going to pick SKX Dev. This is the development queue, which has limitations, but it has a less of a queue because it has a 2-hour max, okay? Tech reservations, leave it blank. Now, maximum job runtime. If it hits 120 minutes, the thing is going to shut down, all right? There's a limit of 2 days, which is 1440 or something input. Oh, they used to have it here, but anyways. And so you could put in the maximum time, but that determines how quickly you are going to access the queue, right? Because they're going to say, oh, you need 1,000 node for 1,000 hours. You may not get it. So you kind of, and with OpenSees, it's tricky and difficult to do. Therefore, you kind of want to be reasonable. Now, number of nodes is tricky because this is what you get charged. So always use the least number of nodes and the maximum number of cores, but think about memory, and this is where the documentation comes in. So that's what I've done. Job name, all of this, you leave as default. I'm all set. Submit the job, and I've submitted my script to OpenSees. Now it's going to grind a little bit, and it's saying, hey, Tapas, here's the job. It submitted it. It submitted it successfully. And now I can go to job status, which I just like to push here. And now you can monitor this job and all your millions of jobs and where it's at. Okay. And you're done. Now you can go back and you can grab your files. You can do your post-processing, whatever you need. That's all there is to it. Okay. I know we've hit the hour already. Then the next, it was getting ready. So that's how you do it on the web portal. All right. Then Jupyter Hub is a different environment. And And there's a lot of exercises and documentation. So now you can do a little bit more programmatic input and running things on DesignSafe. There you can run it at the command language, which is a great way to start running your jobs and testing them, as well as working in the Jupyter notebooks. All right, and OpenSees-Pi and running OpenSees-Pi. So I'm going to show you how to get on so this is just a kind of an overall picture of what's nice about Jupyter. I like it as an IDE because you can manage and move files around. You can edit the files. You can have lots of notebooks and lots of terminal and lots of different things that you can do on there. So let's go and open that up. I got to find who I think we're on here. So now you go back to Tools and Applications, running Tools and Applications. And now instead of clicking, you're still in OpenSees, you can pick the other one, it's the same, and you launch your OpenSees hub. You need to do an additional sign-on, and I've put a lot of notebooks on there that you can play with. I need to do this. Is frustrating because I do this like 7 times a day. Don't copy my number. You're welcome to copy my number because it doesn't matter. Okay. Now, what I like about working in the Jupyter Hub is that you've got this file management, and so you can copy files and move files around very easily. All right. I wanted to show you that once you get on, and it's in all the demonstrations, we can you can open up a terminal window here, and you can just type OpenSees, and poof, you're in OpenSees. Okay. You can type on Python, and you can just say import. Oh, it's such a long thing. So OpenSees-Pi. Yeah, because you need the dot, and I never know. But it's there. So you can run things here, or you can do different Jupyter notebooks and run your Jupyter notebook. So for example, I have one that has OpenSees-Pi on here. And here's my OpenSees-Pi Jupyter notebook, and I can just run it, and it runs. Okay. Or if you want, you can actually go here. Now, go to the terminal, and the console is kind of like Spider or a terminal, and so you can command here, or you can just say, you can just run a script that you have. Okay, and so these are many different ways that you can run it in the Jupyter Hub. In the documentation, there's a lot of different notebooks that I've put here for you to play with. Just trying to navigate back. For some reason, okay. There's a lot of notebooks here that I've given that you can play with. Make sure you spend time on the one with the paths, okay? And learning how to move files around and manage files in your paths. The last part that I think is the most interesting part, and it's really what I want to leave you with, but it's something that you want to get to, is submitting these jobs through Tapas. And there's 4 different parts to this documentation. One is setting up Tapas. It's got some initial setups that you have. It's really cool because I've written a wrapper that you don't have to put in your password every time you do it. There's the function that goes and saves it, or it looks it up. And so I've put a lot of these different wrappers to make your life a lot easier. Okay. So the setting up Tapas, it's about the Tapas pass, as well as, hold on, right here. And looking at, oh, I didn't put the this open. Okay, but pretty much how to connect to TAPIS and look at what's in there. I may be moving some of the content here around a little bit as I get better. There's a whole section on, oh, here it is. OpenSees and OpenSees input for the TAPIS apps, trying to figure out, and what a TAPIS app is, it's exactly what you saw your input in the web portal. All right, and I go in through a whole discussion of it. You give it very key information, and that allows you to then package it and say, hey, TAPIS, here's my job name, here's my input directory, here's the input script. I want you to use this many nodes, this many cores per node, and go. And TAPIS does that, goes, all right, through a Python command in your Jupyter notebook. Okay, and I want to show you how this goes through. And then the last part of this, there's a lot of content also on retrieving your jobs and monitoring your jobs. There's a lot of things that you could do to see what's going on with your job, what was the error, if you got an error that failed, and being able to understand what is in process of your notebook or of your job in real time. Okay, so you can really understand, uh-oh, I made a typo or I did something wrong, and so you can improve on it. Okay, so I'm going to get into doing the live demonstration on this. Okay, now what I would recommend doing is finding your correct page. All right, I'm going to go to community data, and go to OpenSees. There's OpenSees, training material, training. Now I'm going to go to Jupyter Notebooks, and I'm going to grab the detailed and the compact OpenSees MP. All right. The detail goes through step by step to explain what the inputs are. And then the compact shows you that you only need 4 files to run this. So what you can do is you copy these. So Control C, or even with your mouse. Okay, copy. And then I go home. I go to my data. I go to this temporary folder that I've created. It's so funny. I have a few of these. And I'm going to paste it right there. Okay, don't worry about what's there. Now it's in my folder, in my data. I can work with this and I can save it and I can modify it. What I would recommend doing is change the name, maybe put today's date or mine. Okay, and change this right away. So I'm going to open up the detailed one, and this is how cool and easy it is to submit your OpenSees jobs on DesignSafe, and coming up soon, even your OpenSees Pi jobs. All right, this is the little bit of script that says, hey, those wrapper utilities, this is where they are, import them. Okay, and I'm going to import them in here, and every time I call one of these functions, I need to do OPS utils and the name of the function. You're welcome to see where they are. As I use them here, I show them, you can visualize them to understand what's in them, okay? The connect TAPIS, for example, you see it's a OPS utils. So it did that, and it asks for username or password, or actually checks, hey, I found your token file. It works. We can move on. Sometimes some users, if you run this the first time, everything disappears on here. And so make sure you save your file and reload the page. It's the get password app that's the problem. Okay, so here I'm saying, hey, give me information about the different queues. All right, and you will look at the documentation and it's going to tell you, hey, this is the SKX nodes have certain numbers and information about it. This is to help you decide which queue do I want to use. All right, this is unnecessary. This is just information. Now the way you submit the job is you submit a JSON string or a JSON object. Okay, so it's a little dictionary of input parameters in the application. So we're going to use the OpenSees MP S3 application. Okay, there's OpenSees. Oh, this should be SP. Yeah, there goes me with typos, and the OpenSees Express. The version of the app is you're going to use the latest version of it. All right, we're going to put this into a dictionary that only has very basic information and it's not nested. But if you want, you can look at the schema for this app that tells you what are all the, and I have a whole other notebook about all this different information. If you were to set up a job directly through Tapas, you would have to write a dictionary of inputs that's nested, okay? It would be a job's attributes, but then you would have to put these nested. I wrote a wrapper functions that creates this from a simple dictionary because none of these key values, they're all unique. So whether they're nested or not, it doesn't matter for you as a user. All right. But this just shows you what I want you to know what you're working with. All right. Now we're going to say, hey, maximum minutes, and you got to use the variable names that I'm using. Okay. That's why this is a template. And because you'll see if you open up the interpretive, how it takes these and converts them into something. If you're using an SP or the MP, you need to tell it, hey, on Stampede, even though that's a given, the queue that I'm using is the XKX dev because I don't want to wait. I'm going to use one node, 48 cores per node, and then my allocation. Remember, this is all the stuff that we put into the web portal. Now you're just going to put it programmatically. And this here is pretty much fixed, however, kind of thing, right? I'm going to submit many jobs, but this is like the job parameter part that is going to stay fixed. Then the other type of input is to say, hey, and this is where it gets tricky and you'll learn about it, that the TAPist paths get complicated. But I've written a Python package or a wrapper function that gives you, you tell it what it is and it gives you that information. It even saves it for you. If you want to view this file, is actually here. Okay, so this is what I wrote that does all this for you. I see that there's a question in the chat and I'm going to get to it in a second. So now I've told it, hey, all the information needed to know where the basic, whether to go into my data or into work, and then the input folder. Okay, here's the input folder. Remember, we had to fish that up. And then the file name. Okay, now the output, you could just take the default, but if you want, you can output it to work. And so that's what I put it. And again, my interpreter script is going to convert that into something that makes sense for Tapas. And so now this is all the input I have. So you can do this, and then you could say, oh, now just change the file name if you want, right? And now you can resubmit a job, and all you have to do is change a file name. Copy these cells over in a different notebook if you want, okay? And now it's going to, this get job description is going to convert that into something that Tapas. You see how it's a nested JSON now. But I do that for you, or you're welcome to do it yourself, okay? Then I have another task function that I wrote for you that runs the job. And so you say, hey, run this job, and this is that dictionary that we put together, and poof, it runs. It's going to ask you whether you want to go ahead and submit the job, whether you want to monitor it, and I'm going to say, yes, I want to monitor it. Yeah, this one doesn't show it because it's saved, but it monitors it and shows it to you. I think I should have one that's here that I did before. Yeah, so here it is submitted, and this shows you, and now you're sitting here waiting, or you can leave it if you want, but it shows you, hey, I'm processing the input, I'm staging it, I'm running, and so here's the OpenSees analyses took 26 seconds, while moving my files took 630 seconds. Okay, so I'm working on making that faster for you as well. I've also written some functions on top of that that allow you to visualize your output. I guess we'll put it on this one that I had just run. You can look at all the job information, the job metadata. This is interesting for me, is to look at how much time everything took, because now I can try to improve, you know, how I submit jobs, or maybe different nodes, different times, different options. There's a lot of, this is something you go into if you have a problem, if it fails, because you ran out of time, because there's a typo in your input file. These are the important files. And what you want to do is you want to look at TAPIS out. And so I wrote something that puts them into nice and visual for you. Or you can go here. Remember that we were in job status, view jobs. And if a job is complete, I can almost hear it crunching, right? So you can look at the output here, and it's the same files, and you see that they get saved somewhere in your storage, wherever, and it's this TAPIS archive with the job name and everything. This is the data that you sent, and this is that .out file that you want to look at, because this is almost like the echo. All right. Careful how much you echo to the screen, because that takes time, but this is telling me, hey, everything worked. Right? This is it running. I'm checking that I've got different PIDs running OpenSees. So I do have the many different parallel processors running. That's something you always want to make sure that you check. Okay. And so these are the notebooks that I've put here for you, that some go into the details of the app, some show you steps. And then this last one, for example, all you have to do is, so this is the common part, right? Talks about the job. And then these are the individual runs. And that's all you have to give it, is a few inputs. So I'm showing you how you do it from my data, from community, or you can put here a different case or a different something, and it's all within your notebook. And that's the beauty of being able to not, GUIs are so 1990s is the line that I like to go with. We're back to being able to have a little bit more control in what you're doing. And pull down menus are great for one-time thing, but when you're running a lot of jobs, you need to step up and have a little bit more control. Okay. We have 2 questions here. Do I need to copy the notebooks as I am going to change to meet my needs? That's up to you. So yes, I would always save a different notebook for a different project, right? It really depends on what you put in the notebook as fixed values or not. So that's what I do, is I always back up and duplicate my notebooks as I go along in the daytime anyways. So, and then can we run from Visual Studio Code as an IDE in our local machine to run OpenSees on DesignSafe HPC? I think if you can set up, I think Professor Arduino does something like that, because TappyPie is an API that could be accessed somewhere else. And so you might be able to, but I wouldn't, because now your input files are here, but your output files are going to be somewhere else. You're still going to need, if you submit it, it needs to load your input file in your own input directory. And so uploading that from home may not be the best way to do it. I would recommend that's the whole point of the Jupyter environment, is that it works just as well. I mean, you can take your Python script and visualize it and run it here, just as if you were in Spider, right? I've got the editor, so let's pretend it's an input file, so I can edit the file, and then here I can just put in the command. So you could do what you can do in Spider, you can do it in the Jupyter Hub. Yeah, okay, so let me go back to the last slide. And live demos went. Okay, so now so those are the demos. Those are the 3 different ways of doing it. I've put many different types of ways that you can do your analyses on DesignSafe. The more you learn, the more power you have. And so the resources there's user guides, there's these modules. I'm hoping to do more advanced webinars, maybe more bringing people in to learn about how different people are using OpenSees on DesignSafe. Please use the Slack channel if you have questions or contribute, or build a community or kind of something of just saying, hey, this is what I'm doing. Anybody working on something similar? If you have big issues, submit a ticket. I respond to those when they're related to OpenSees. The problem with tickets is that they're a funnel and it's not something shareable. So if it's something that could be asked in the Slack channel, I would prefer it because then it's reusable information. And as a last resort, you can message me. I can help you. We can have one-on-ones. I like to have office hours. But anything that we can do that's repeatable, kind of like code, is ideal. So, in summary, I have no idea. Just Google it on how to connect the Slack channel. I think if you have an account, if you look at the user guides, there must be something there, and I'm going to make sure that there is instructions on that. So I think you may have to submit a ticket or something. I don't know how to connect it. So in summary, all right, and now if anybody has questions, I like to open up the question forum here, is everything, DesignSafe gives you a computational environment that is beyond just computer nodes. It is a collaborative environment. There's a community, there's meetings, there's a lot of human resources that you can access. And just the way that we interface with it. I've been working a lot on that, on making the usability of OpenSees better. And I'm going to be bringing OpenSees Pi into being able to do everything that you can. Thank you, Natalie, for the link. So there's a link there on how to connect to the Slack channel. So my recommendation, if you're getting started, is start with a minimum working example. All right, use one of the ones that I've given you. There's like all of them. There's SPMP and this and that. Test it in the Jupyter Hub so you get yourself familiar with that. Doing things on the terminal, don't be afraid of typing things in. If you look at the documentation, it shows you how to do the MPEXE, NP equals 3, and blah, blah, blah. Then edit. So first make sure it runs. You can run as is. Then edit it to see if, hey, I'm going to do something different to it. Test it still within Jupyter Hub. Then when you're ready, submit it to the web portal. So right now, that's just a tickle version, I know. And then also everything I've said, all these Slurm ones. Oh, yeah. I'm going to create an app, a Tapas app for OpenSees Pi, because right now it just calls OpenSees. And then once you submit it on the web portal, use Tapas to look at your job while it's running, or if it has run. The more problems it has, the more interesting the output looks. And so it's a good way of getting familiar with the post-processing as well. And then when you're ready, try to submit that through the Tapas app. Work with one of the detailed examples that I give there, one of the detailed notebooks, and then jump or delete file, or, add in your own information. Feedback, anything you can contribute and send back to me or put in the forum would be great, how we can improve it. But then it just becomes very few of us run one script one time. And so being able to program this whole process, and the advantage of Tapas is that you don't have to move the files. It does it automatically for you, which saves you a lot of hassle. And I'm going to have tricks on how we can speed up that data transfer. So stay tuned because I'd like to do some more advanced things. So catch up with me, do all these things so that when we have the next workshop, hopefully a workshop more than a webinar, we can do some really interesting stuff if everybody kind of gets up to speed on these things. We can really open up and turn the little wheels of things. Okay, and thank you for being here. And so right now I'm open to questions. If anybody wants to just turn on your microphone and speak, and it'd be awesome if 10 people want to speak at once. Anybody out there running something right now or in the process of doing something? Yeah, Bakas.
Yes, so as you were asking that anybody is running something, so yes, I'm running on OpenSees SP. So I'm running one of the, I mean, some models there. Yeah. So I have like, I was also like wondering. So when I am like submitting job there, so I'm noticing that for one simulation, I'm feeling like that it's taking more time over there on HPC as compared to when I'm running on my own computer. So what could be the reason for that?
Oh, interesting. Uh, are you submitting it through the web portal?
Yep.
Okay. Look at the actual, use that, one of the packages that breaks down at the job duration, how long each step took, and you're going to find out that it very likely is the moving the data. We're going to post this on the DesignSafe page. So I think that's what's adding on to your analyses is just the setting up the job and archiving the data. So if you reach out to me and if you're already doing things, I can help you with that. Um, as well as, and so you got to profile and see what it is that's taking a long time. Now, sometimes, I mean, I have a gaming computer, which very likely could be faster than the Stampede 3 machines. Um, but the improvement is the scaling up of not having my machine be busy. My data is already in place. And so all the other benefits. But yeah, I would profile your analyses and the job to find out what is slowing it down.
Yeah. So because like right now, as far as like data is concerned, so data is, I think it's in like my data. So on the
Yeah.
data
So
depot. Yeah. So it's
yeah.
just taking data from there.
Yeah, so reach out to me and we can look at a job. I can send me a message on Slack and we can set up a time. And I love to show you how to do this. Or there's one of these notebooks that the job, view the job,
Okay.
that shows you that you can. I've written a whole package that shows you what the different steps are. Try that and then reach out to me and let me know what it says.
Okay. Okay. Sure.
Okay?
Thank you so
All right.
much. Appreciate it. Yeah.
Oh, you're welcome. Juan Carlos, you had your hand up. Yes.
Good night. In my case, thanks for the presentation. It was really interesting. My question is related with the time. So if I need to perform a parametric analysis for my research, where the time it's more than 120 minutes, which option do I have to use more the computational power of the HPC of that database or something
Yeah.
related with the same safe?
Yeah, so the limitation is not 120 minutes, it's 2 days, 48 hours, okay, to run the jobs. I believe if we look at, okay, I lost everything here. Let me open up the documentation and I have it there. So you have 48 hours, okay, on the SKX nodes, okay? Um, oh, it's on the other browser. Over here. Okay. So you have 48-hour limit. Okay. Now, if you're doing parametric analyses, are you individual analyses taking that long, or is it just because you're running many one after the other?
In my case, it's not take so many hours, but there are a lot of analysis in
Okay.
parallel or a lot of models to run.
Yeah. So this is
Mm,
really cool. Okay. Are you doing this in OpenSees MP?
no, no, no. Currently, I'm doing. I found the QFM that it helped me to run a lot of analysis with the model, but I'm not using any kind of MPA or something like that.
Right. Okay. So a couple of things with yours is switch over to. So QuoFem, I think, kind of creates the OpenSees input and then runs it, and they may have limits of 2 hours. So if you could pull out your script, you can actually run things a lot more um, on Stampede, and you can parallelize these. Are these Python or Tickle?
Python. It's Python.
Okay, even easier.
Yeah.
So then a couple of things. I mean, you could literally just submit them to Tapis, and you could submit many of them, and you have a 48-hour limit. So package it that you run this, in 48 hours, but you can ask for 100 nodes or 10 nodes or, and each node has 48 processors. So check your memory needs and things. And so think about how you want to parallelize it is really the key.
And for example, if I would like to do some machine learning analysis using the GPU, in my case, I'm using after the analysis with the QFN and download the models and trying to use my own GPU in my laptop. But it's possible to do something to training in the HPC also.
Yeah, there's a lot of, and so that one, I think there's other modules on machine learning modules, because that's independent of OpenSees. So if you go to the training, I think Professor Kumar has some machine learning, or you just submit your jobs in the ways that I've shown this. But look at the training for the machine learning, because those are a different type of analyses, because you're a different type of, it's not like a simple parallel sweep. But yes, so that's possible. And you can use the GPUs. We have GPUs available on DesignSafe. So it really depends on what you're trying to do. So yeah, go on go ahead.
Just where I can find the machine learning
So you
that
go
you
to
mentioned.
user guides in DesignSafe.
Okay.
And you go to, you see they moved training resources here, and there's accelerating Python with training. I think that's a machine learning one. Deep ONet. I think these are all physics informed machine learning. So there's a few modules there for machine learning implementations. Okay. And I don't know if these are about machine learning itself, but yeah.
Okay.
Yeah, lots of resources there. So yeah, because then there's what machine learning is, and then how to do it on DesignSafe, and hopefully those modules have. There's a question here that somebody's having trouble. Yeah, so Dewan, currently having issue with launching OpenSees Pi on Jupyter Hub. And then you've got the screenshot. I would pick the recommended. Always go with recommended things. So what the trouble, this issue is just you got to pick one of these, right? So if I log out of my design of GitHub, I'm not going to because I have too many things. But if you log out, and the way to log out, and I have it there, is to Hub Control Panel. Then it asks, which Python do you want to connect? And on yours, you've got 2. Me, I've got 3 or 4 choices. So connect to the recommended one, Python 3.12, because I'm pretty sure I know OpenSees Pi works on there. And so then if you go to the document I wrote, there's a lot of content there on running OpenSees Pi on DesignSafe. Yeah, when you have pull down menus, I'd always click on anything with a star. So did that help the one, or are you? Okay, good. Any other questions and things? Andreas, do you have any questions? We have someone who, are you developing or working with OpenSees Fresco?
No questions here, Sylvia, sorry.
Oh, good, because you know everything already, so. Oh, Hanshu, yes.
Hi, that's a really good presentation. Thank you very much. I just have one quick question regarding the maximum runtime. That was a great question from the last one. What my code is that I'm running like a Monte Carlo simulation, so that I want to run the OpenSees MP. So for example, if I want to run like one node, or like is that I just wonder like what's the maximum of the processors in a node? Or for example, if I want to run like 100 times series, and then I want to run the parallel computing, do I need to set up that 100 series parallel computing code first in my Python script? And you input the same number of processors I use in the OpenSees, or I just I just have a script and then just run the input number. Yeah.
Okay. Yeah. So that's a loaded question. Okay. Be very careful. And I think there's a really good video that Frank wrote about load balancing. Okay. When you run things in parallel. And so running things in parallel, it requires, sending, okay, this run, you run this run, you run that run, you run that one. OpenSees-MP is great because it does that management for you. At the same time, you have to tell it, oh, and you don't have to put in your script how many nodes and cores you're using, all right? Because you put that into your job submittal, and then there's a command in OpenSees-MP, and if you look at the scripts that I have there, it says, give me NP. So tell me what number of processors I'm working with, and it tell me what my ID is, because OpenSees-MP is many instances of the same program. And now you decide how you want to do the analyses. Do you just distribute them like cards, or do you put them in a leapfrogging type of algorithm? Because some analyses may be super fast, and so maybe one processor is just going to sit there and be done while another processor is doing something else. And so there's a lot of planning and thinking about that when you're doing these parallel analyses. Or you can use a Slurm to do it, and you can but OpenSees-MP, that's the nice thing about that. Now, in OpenSees Pi, you can use the concurrent futures. And so a lot of that is just how to manage the analyses themselves, whether you're doing it in DesignSafe or not. There's a lot of really interesting and different ways that you can optimize your distributed analyses. And remember, every time you distribute it and you send something to another processor or core, that takes up time. That takes up management time, all right? So sometimes it may just be faster and easier to just run things in a single processor. Not always, okay? But I'm just saying you've got to take the expense of managing jobs. And do you do that? Do you let OpenSees manage it? Do you let the Slurm manage it? Do you do it by sending many different jobs at the same time? So there's many different ways that you can optimize your time as well as computer time.
Sure. Thank you. Yeah, I'm thinking about using the web portal first because I have the web portal account. So I'm thinking about using the web portal and then upload my Python script, like OpenSees Pi script, with the Monte Carlo simulation. I set up the number of time series, and then I'm trying to see if I can just type in the node core, type in the processors or cores to run a parallel simulation to see how.
Yeah. Your OpenSees-MP script, you should be managing who does the jobs. But right now, if you have, but OpenSees-MP on OpenSees Pi, is that how you're doing it?
Yeah, I the OpenSees Python in my own computer to build up the code, and I'm thinking about putting.
Are you running it through an MPI? So you're doing MPI, blah blah blah, OpenSees?
Yeah, kind of. Yeah,
Okay.
that's what I'm about using MPI.
Yeah.
Also that to the
so look at the documentation that I have in there in the Python and Jupyter environment and things. Because right now you can't submit through the web portal an OpenSees Pi script yet.
Okay, sounds good. So I can just use the Jupyter Hub,
Yeah, try Jupyter Hub and give me a little bit while to get approval to get this app. Because then I keep on wanting to add things to it is the problem.
Okay, no problem. Yeah. Thank you so much. Yeah.
You're welcome. Other questions? Anybody want to share what you're doing and things that... John, I know you're going to give a presentation on your OpenSees analyses at the end of October. So any questions?
No questions right now. Just still running everything kind of local on my computer. So haven't progressed yet to doing any of this MP stuff yet.
Okay. Let me know if I can help.
Will do.
Mm-hmm. All right, I'm going to give you a 3-minute warning if anybody has more questions right now. Otherwise, we can go off to lunch. And thank you for the great feedback on here. Reach out on Slack, get on Slack, and share what you're doing that others may be doing something similar. And let's be a resource for each other, kind of thing. I've been told I can use OpenSees to create a digital twin and integrate sensors for real-time updates. Oh no, you just missed Andreas. Are there resources you would happen to have to help me to get started? Yeah, it really depends on how you want to integrate this real-time data. If it's really real time, or is it something that just happened a minute ago? And I don't know what they're doing with OpenFresco. So OpenFresco is a way of opening up the API from OpenSees to an outer channel, typically for pseudodynamic testing. But I believe that why not have data? So yes, there are ways, and I think that's what OpenFresco said. It's not quite on DesignSafe, but it'd be interesting to see if you make something out of that. Let me know. And so Andreas Schellenberg, who was just here, he's the one that's been doing the maintenance work of OpenFresco, I believe. So Google it and see if that's where you want to go. All right. Thank you, everybody. I'd love to have this be the beginning of a longer conversation, and go and OpenSees. Thank you.